Thank you. Hi again. So thank you all for coming, and thanks organizers for inviting us on this great event. Today we will talk about testing an API. We will actually focus more on the concept of testing and examples, and we won't go through code because it's a short talk. We'll show you some things we learned along the way, and we hope you hear at least one thing that will be helpful for you in your projects. My name is Paula, and I'm a backend developer at CUCUK. I mostly work on Symfony projects, but API platform are my favorite ones. Okay, this is Antonio.
My name is Antonio. I'm the CEO of CUCUK. For the last 10 years, I'm also into software development, mostly backend with Symfony framework. For the last 8 years, I'm using Symfony. It's nice to be here. Thanks sponsors and organizers for inviting us to speak here. Before we just start, just a few words about our company so that you can get the context what kind of the things we are building. So we are located in a Split, Croatia. That's the south part at the sea. We are not a big company. We are only 20 employees at the moment, and we are doing custom software development for the clients. So for example, on the API platform, we have a project that is running in 26 countries, supporting the biggest amateur marathon organization in the world for the bicycles. So yeah, that's the kind of the projects that we love to do. Some of our clients are also telecoms, banks, and some small startups. Before we start, just a question, who is not writing tests here? Let's be brave, come on. There are for sure people who are not right. Okay, we will try to focus today our talk about why you should write tests and how you should write it properly. As Paula already said, we are not going into details how the test in the code should look like, but more how you should think about the test that you are writing. So let's start with one simple example. This is the Mariner 1 rocket, which was released in 22nd of July in 1962, but it took almost 30 seconds and they needed to crash it down because they have a small bug in the system. The developer who was transcripting the formula for calculating the track of the rocket did a small mistake. He didn't write down the small superscript, and the result was $135 million just lost, burned out, literally. Fortunately, there was no human victims here. So basically, you are maybe not a rocket developer, but still your bugs that if you are not writing the test, you probably have more bugs in your code than with the test. They are costing some money for your company, for your clients. And estimate is that at the moment, the cost of the software bugs is more than $1 trillion of US dollars in the world. So why you should write a test? First thing is that you will reduce the number of the bugs. And I already said that now the bugs are costing some money. And of course, you will get annoyed customers and annoyed clients if you deliver the software with the bugs to them. Second thing is that you will improve your code quality. So if you have quality code, it's much easier to test it. If you have like really messy spaghetti code, it's almost impossible to write tests for that test cases. So usually writing the code will improve your code quality. Next thing is that it's easier and faster to refactor. For example, to be honest, I have one project that I'm working at the moment which doesn't have a test. It's also one API thing. I started to writing the test because I'm annoyed I changed something and then I messed up like 6-7 endpoints. And then of course I don't know that happened because I started to working on that project a month ago, and project is also already like a year under development. So if I had a test, if everything was properly, or at least some parts of the application were tested, it will be much easier for me as a new developer on the project to change some things. Of course, it could be used as a perfectly use case-based documentation. So if you have a new developer, or even if you have a project that you work, like we had a situation where we had a project that we worked like a year ago, and we got some requests from the clients to upgrade the system, and we didn't have the proper documentation, but we had everything covered with the test, so that tests were documentation for us. You can believe in the fact that you will remember what you did like a year ago, but that will not happen. Like usually you don't even remember what you did 2 months ago, and I'm talking about a year or 2 years. And last thing is time and money saving. Writing the test will save a bunch of money and time. And for us as developers, software testers, whatever, our time is actually the money. So this is this very simple graph. On a long period, if you have tests, you will just start producing more faster and save a bunch of money on testing, writing new features, having quality software, whatever.
Okay, so now that Antonio convinced you that you should write tests, let's see what is a test pyramid. I'm sure most of you already heard of it. So basically it's a graph which is telling us how much tests we need to write on each layer. So the lower layers have more isolation and they are much faster, and the higher levels have more integration and they are slower in the execution. So the point is to cover as much as of your logic with unit and integration tests, and have as many and have only a few functional tests. So let's start from the beginning. Those are unit tests. So unit testing is a level of testing where individual units are tested as isolated. One unit is one smallest testable part in your application. So that basically means you should take each of your methods and isolate it from other methods and test it separately. If your method has some dependencies, like it calls some other methods or some other classes, you should mock them. And I think unit tests are very easy to write, but sometimes you come across something like this. And I think it will take you at least an hour to cover all the possible cases here with unit tests. But that doesn't mean it's hard to write tests. It means this code is badly written. I think we can all agree on that. So each time you're having trouble testing something, it means you should do some refactoring. Refactoring can be easily done using solid principles. Solid principles is a set of design principles that show you how to write good code, clean, elegant, and readable. Also, that code is easy to maintain, and code that you wrote using those principles is really easy to test. If you haven't heard of these principles, I suggest you research a little bit about that. So now that we tested each method separately, does it really mean that our application is working perfectly? Not really. We also need to check if our methods work together when we use them combined. So that's where integration tests come in. So integration testing is actually testing each individual software models and combine them together as a group. Let's see when we should use them. First is validation. So when we want to write the test validation for some class that has some validation rules, we should in the test we should first create an object of that class, and then we should intentionally set the wrong data into that object that will break the rules that you wrote in our validation. And then we will trigger the validate method, and then expect that method to return the validation exceptions we want. Next thing is third-party integration. So in the unit test, you will usually mock the calls to the third party and assume it works okay. But you should also write some integration tests where you actually trigger the third-party methods to see if your application actually works okay with that. Database queries. So if you write some query, especially some more complex and big one, you can't really be sure it works okay with just unit tests. So here you really need to make an actual call to the database to see if that's working. So first of all, you need to know the exact state of the database. Before the test, you will prepare some data, and then you will make an actual query to the database, and then assert if it returns the correct results, or maybe if updated something, deleted something, depends on what your query does. And in general, you should use your integration test for any two models that work together to see if they are working okay. Okay, the last are functional tests. That is defined as testing of complete functionality of some application. They are much simpler to write in the API compared to an application with a user interface, because when you have a user interface, you need to create a crawler that goes through your website and then fills some forms, clicks some buttons, and then you expect some element to show up or hide on your application. But in the API, you just need to send an actual request to an endpoint and assert if the response is okay, if it has some content you wish, and so on. Okay, so now let's see how does one functional test look like. So first we need to send a request to an endpoint and check following things. So first we want to know if it returned the correct response code. It can be like OK response, bad request response, and so on. We should also check header. It can be, for example, content type JSON or something similar. And then we assert the response content. Here we just want to check if our content has the correct fields in response and they are in correct format. We don't need to test actual data from the database. For example, if you have some pictures and then you generate randomly first name, last name for users, so you don't really know what's in the database. Later we'll see in the PHP-MAЖAR library that can help you here. Okay, so now let's see if we want to test one single endpoint, what we need to write. First of all, we need to send some OK request, and we need to check if the application returns OK response. Then we should intentionally send some bad request which breaks some validation rules, and then assert it returns validation response. But don't overdo it, you just need one test that will break validation. You don't need to test for each individual error because you already covered that in your integrational test. And you should also check if your application handles correctly some security endpoints. For example, you can try to get something that only administrator can see as a regular user and expect it to return access forbidden response. Okay, let's see how we can test solving puzzle feature. We will just see what type of assertions you need to make. We won't show code because we don't really have time in this talk for that. I hope you will get the picture. Okay, so first of all, we want to cover as much as we can with unit tests. We have here a single piece of puzzle, so let's think what it should have, what features should it have. So it needs to have some picture, it needs to have some shape of a puzzle, we need to be able to move it around and merge it with other puzzles. So we will make those assertions. First we'll assert it has image, it has a puzzle shape, assert it can be moved, and assert it can be merged. When asserting that it can be merged, we need actually some other puzzle, that's some other piece of code. And here, because these are unit tests, we will mock that other puzzle and assume it works as we expect. So now let's go to the integration tests. We try to merge two puzzles that fit OK together, and we will assert that it actually returns OK response. But now we should check what happens if we try to merge some puzzles that don't fit OK by shape. And we need to assert that an exception is thrown if we send something like this. Okay, now that we know that our program works OK for the error of different shape, we have also the case when our shape fits OK, but our image doesn't fit OK. So we also need to make a test for that. So we should assert that also it throws an exception. And now that we all covered all validation and unit tests, we are ready to go to the functional test. So here, let's imagine we have an endpoint with a post method that accepts a solved puzzle and check if the puzzle is solved correctly. If the puzzle is solved as it should, response will be okay. If it isn't, it will be some bad request response. So we send a correct solved puzzle and expect to get an okay response, and also we check headers. And now we just send one request with a badly solved puzzle with one piece missing, and we assert it returns bad request response, and we assert it has correct headers. So okay, let's see some things, some random tips that we learned along the way while we were learning how to write tests. So you will usually find on the internet that you should write your tests first, but that's maybe pretty hard if you're just starting. You need to test some code that doesn't even exist yet. So it's just one of the approaches. You don't need to write your tests first, but that's a pretty good approach too, so you should definitely give it a try. It's actually called TDD, Test-Driven Development. You will also find discussions, do you need to have 100% coverage? But that if you do have 100% coverage, it doesn't mean your code is fully tested and working, because 100% coverage actually means that your test used each line of your code, and that is not meaning your code is working as it should. We also learned that we don't really benefit from writing a unit test for some simple methods like getters and setters. They really take time to write and maintain, especially on big projects. But you will also find some sources that tell you that you need to cover everything. So I suggest you try both ways and see what works the best for you. So what about the legacy code? You may have like a big application already running, no tests, but you would like to write some tests and you're not really sure where to start. Well, one way is to start by replicating bugs with tests before fixing them. So each bug you find on your application, first you write test, and then you fix it. That way you will make sure that bug won't appear again. Another approach is just start by writing tests for the most critical parts. That can maybe be payment, checkout page, registration. You might have some deadlines and clients and don't have time to go all from the beginning and test, but this will be good enough until you get the time and test it fully. And you can come across some specific code that you're not really sure how to test and how to approach it. A good thing can be to check out the tests of the libraries and frameworks you are using, because there you will get some ideas and see how they did it. You can learn a lot by that, not also about testing, but also about writing code in general. And now that you wrote tests, you're not really sure, are they really good enough? Did you cover everything? Well then, you should ask yourself, am I sure that the code I tested works as it should? So if you're not really sure, you wrote a test, but you can't guarantee your code works, then you should write more tests for that part. If the answer is yes, you're okay. But if you're still not sure, there are some tools that can help you check the quality of your tests, and Antonio will show you some of them.
So, of course, as Paula said, if you have 100% of the tests covered with the test, that doesn't mean that you have proper testing suite. So basically, what is the most important thing is to focus on, let's say if you have a limited budget, for example, and you have e-commerce solution, something like that, you should every time cover the test from checkout process and registration. If contact form doesn't working, that's perfectly okay. But if your checkout process doesn't work, that's the issue. One of the tools for checking the quality of the testing is infection. Who is using infection already? Okay, so few people. So infection is a PHP mutation testing framework based on abstract syntax tree mutation. And mutation testing evaluates quality of your testing tests. So in a nutshell, it works in a way that runs the tests and see are all of your tests are passing, and then mutates the source code with set of predefined mutators and see if each mutant will fail. If some mutant is fail, he'll count that as MACI, which is mutant score indicator. You can see it here. And this is code coverage. So in this situation, we have 100% code coverage, but our MIC is only 67%. Why this number is important? Because we can define what is the lowest possible number that we can accept as a good test solution. So basically, that's on you. Usually, you want to reach 100%, but sometimes maybe 75% or 80% is enough. Second thing is static analyzing tool, which is called PHP Stan. Who is using PHP Stan? Okay, much more people than infection. So it caches all the classes of it catches the whole classes of the bugs before even tested the code. So what it's trying to do is trying to move PHP closer to the compiled languages in sense of correcting each line of the code before even is executed. It's very easy to start using this because you just need to download the library and run it in console. So yeah, that will be nice to start. Also, I hope that all of you are using some kind of continuous integration at the moment, which will save a lot of time for you, like with deployment, with running testing automatically and everything else. All the tools you can integrate in your continuous integration system, and then, of course, you will save a bunch of time. So, yeah, more handling testing tools. The first one is from the API platform, which is called the API test case. I think that Kevin is doing an amazing job with all tools that you are providing to us, so thank you a lot for that. There is also the Panther for functional testing and other things, but this one is very good because it gives you out of the box a lot of methods, and what's the most important thing, it manipulates the Symfony HTTP kernel directly to simulate HTTP requests and responses, and you will get your test running much faster than if you are doing that through the network, like through the Postman or something else. I will show the Postman later. So how it works, actually it's very easy, because you just need to extend API test cases and you get all bunch of the assert, like assert JSON equals, assert JSON contains, and other things. But I think this is the one that saves a lot of time, because basically on classes that you expose it and as your API responses, you can test against collection or against item JSON schema. This is very, very powerful tool, and again, it's very easy to use. PHP-MAЖAR, okay, is one that allows you to perform pattern check against your responses. So usually, if you change the database, you will have different IDs or different string, depends on the data that you are using. So what we want to achieve is that we can check the pattern of our response. So for example, if the ID is a string, if the IP is really IP, is some array is really array. So we have a bunch of these available patterns, but we also have some available patterns expanders. So we can check if something is a string, and then if that string is an email, or is that string starting with something. So here's the example, how it looks like. So I have some simple response here, and then I'm checking here, for example, for the roles. Is that array is not empty, and do I have role user inside the array of the roles? Also, for example, at the created field, I'm testing is that a data time. So this is also a very nice library that will save a bunch of time for you during writing the test for the API. Who is using Faker? Nice. For people who are not using Faker, Faker is an amazing library that enables you to generate random data, but data that has a sense. For example, if you need a date of birth, if you need city, if you need country, phone number, IP address, whatever, you can generate it very easy with some of the methods that Faker is providing. So when you're starting a new project, you don't have a data, Faker is an amazing library that you should start using with. And then if we are combining the Faker and PHP-MAŽAR, we already have amazing tool for generating some kind of real data, let's call it in that way, and testing the response with calling the PHP-MAŽAR on that set of the data. Last thing that you can use that we put in these slides is a Postman test. So this is very easy way for writing only the functional test. You cannot write any other test instead of only the functional test. So what you do with Node.js, you are writing it's very easy to write a test. You have already some prepared methods. What is handy here, you can test the time of the response over the network. So that's maybe a nice thing what you can use for the Postman test. Also inside the Postman test, you have few libraries. One is give you a possibility to test in the same way as PHP-MAŽAR against the pattern. You can run the test automatically inside your continuous integration or inside your console. You just need to export your collection of the test, import it in your project, and with a Newman, you can run it directly inside the console. And this is also nice because the front-end developers will have very nice documentation where they can play and experiment with that.
Okay, so let's wrap things up and see some conclusions. These are just a few things that we would like you to remember from this talk. First one is that you should write tests. Well, most of you are already writing, so we are okay with that. Secondly, it's very important to write unit integration and functional tests. Writing only one of them is not really enough, and you can't be sure it really works. So when we first started writing tests, we were having some smaller application, and we were writing only functional tests. And it worked pretty good for us, but then we came across a bigger project, which was lasting like for 2 or 3 years now. And after 2 or 3 months, those tests were just too much. They were lasting like for 1 whole hour, and we weren't really able to cover all possible cases with only one set of fixtures. And that's where we realized why unit and integration tests are really important. So we broke all the things up to unit integration tests and left just functional tests, just to check if each endpoint works. And it really, now we have like really lot of more tests than we used to have, but they are lasting like a few minutes. And we can run it all the time and check if we broke anything with some new changes. So if you ever come across something that you're really struggling to test, or you don't really know how to test it, then it's time for refactoring it. So that's the time where the tests really help you to write more quality tests. And be sure to check out the tools we mentioned. If some of the tools you're not yet using, they are all pretty easy to integrate to your application, and they don't take much time. And they can really help you to write better tests, and most of them can be integrated in the GitLab continuous integration. So each time you push some code, you make some pull requests, you can set them to automatically run, and the person who is reviewing your code is able to get a better picture of your pull request, and also it will ensure that none of the bad code will turn up on production. Okay, that's it. Thank you so much for your attention.
I think we have like 10 minutes maybe, so for questions.
Si vous avez des questions. Ça a été clair? Non.
Yeah, there is one.
Pas complètement.
Hello, thank you for this. I was wondering if you include the QA engineers in this process of writing tests, or if you're just doing it alone as developers.
So you were asking, do we have a QA?
Yeah, or working on the test with the QA.
Yes, actually we do have a QA. So we try to cover as much as we can with our tests, but as we have like a developer mindset, and we don't really think on a way that some person who is not in the development. So we also have a QA to check it out and to see if we missed something, some edge cases and so on. Actually, QA was working on some of the projects we didn't write tests, and on some projects we did, and it was like a huge difference. There are like only a few bugs on the whole application, so it really did help to make more quality applications.
I think the part of the answer that Paula missed is that our developers writing the tests, but yeah, there is QA who will check that after. But at the period, I don't know, 2-3 years ago, when we started to write tests on every project, the number of the bug that QA was discovering drastically reduced. Because if you just think about test, even if you don't write it first, if you write it later, it still forces you to think about some edge cases that maybe you skipped during writing the code. So yeah, you will find some bugs.
And yeah, sure, when a QA finds some bug, then you should definitely cover that case too. Thank you for your question.
D'autres questions?
Yeah, one question here.
Thank you for the presentation. We are talking about API testing, but we didn't hear nothing about Swagger, OpenAPI, and tools like that. I saw the slide about validation of input and output parameters. But today, with the automatic generation for clients and servers, the validation is, I don't see it as a major factor. Do you have something, did you work with the tools like Swagger or OpenAPI? And if yes, is there a way to integrate the tests directly in these specifications?
Actually, yes, the PHP-MAЖAR is okay when we are not using the tools you mentioned, but I never actually worked within Swagger and OpenAPI. I think Antonio had some experience maybe with that.
To be honest, what we did, we exposed the documentation Swagger API, then we implemented for some projects in Postman, then we use it there. But I never, to be honest, validated against the model. I was mostly taking all the API calls and then run my own test on that. But I assume that is possible to do because I know there is in API platform on a front-end application there is fully valid validation based on documentation that you provide from the API platform. So yeah, that should be possible, but I never use it.
D'autres questions? Sûr? C'est clair? Bon, ben merci alors.
Thank you.
Thank you. I forgot to mention you can find the slides here on Joined In, and you please also rate our talk. Thank you.